Welcome to Ask and Learn.
The first question we have here asks us to write the alpha decay equation of americium 241. In alpha decay, we witness a helium nucleus being ejected from the isotope. Consequently, we will have to subtract our numbers so that they even out on both sides. And the resulting isotope will be 237 neptunium. The next thing we're asked is the complete decay of this original isotope of americium 241 involves an order alpha, alpha, beta, alpha, alpha, beta, alpha, 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 beta, alpha, and finally beta production. What will the final stable nucleus be produced by this decay series? And then, in part C, identify the 11 nucleides that come in between them. So we're going to go ahead and analyze this together. So we have our first one already done for us. When americium undergoes alpha decay, it will become neptunium 237. The second one, according to the question, was another alpha decay, which will result in it being protactinium 233. But after this, we will encounter a beta decay. And in beta decay, you encounter an electron being ejected after a neutron has decayed into a proton, thus resulting in an increase in atomic number. So in this case, we will see this protactinium becoming uranium. After that, we encounter yet another alpha decay. So we will subtract 2 from the atomic number and result in thorium. The thorium will then undergo an alpha decay and we'll get radium 225. And next we encounter a beta decay, which will result in the same atomic mass, but an increase in atomic number, thus being actinium. From there, we go back to alpha decay, which will result in francium 221, and then we will undergo yet another alpha decay into astatine, followed by yet another alpha decay into bismuth 213, which then undergoes beta decay. The beta decay will result in polonium 213. This will then transfer itself into an alpha decay into lead 209, and it will then finish off with a final beta decay into bismuth 209. So the intermediate nuclides that occur will be the following. Because all of these happen on the way to stability, or relative stability, as it were, all the way down to bismuth 209.